Hi guys, utilization of electrical energy. Today I am going to teach you explain of laws of illumination and its significance. So, what is laws of illuminations? To find the illuminations at any surface, there are two laws of illuminations are to be considered. First is inverse square law, another one is Lambert's cosine law. Now we start inverse square law. Now you can see from the figure here, this is a point source. This is the source of light. Yeah, so in illuminations received on any surface is inversely proportional to the distance between the surface and the light source. This is the statement of this inverse square law. So we just consider that this is the area. So here we take a source, point source as a light source, and we consider 1, 2, 3 and 4 areas parallel to each other. Now this law is applicable only for the point source of a light. So it is the prerequisite. Point source of light and the perpendicular distance from the source of the light. So this is two are the prerequisites for the inverse square law. Again I repeat the things. An illumination received on any surface means if I am going to receive in this surface 1, so the area of this surface is A1. So I receive the illumination at surface A1 on any surface is inversely proportional to the distance between the surface and a light source. So here if I am consider this A1, so distance between the light source and this area I consider as X. So it states that it's inversely proportional to the distance. So 1 by x square. Now we prove this square law. So inverse square law, consider a point source of a light, yes, as shown in the figure, with an angle. So here we consider a solid angle. So this is the angle. Okay, so solid angle. Three parallel source of areas. Here I consider three source of areas A1. Here is A2 and here is A3. Okay. Okay. Now the distance from the source, light of source, point source to that particular area is D, 2D and 3D. So from the point source 1 by 1 as shown, let I is the intensity of illumination of the source in that given direction. Okay. Now illuminations, as we stated earlier, I will explain you. Okay, what is the illumination for that particular area A1? So the illuminations for that A1, A2 and A3 are different. So illumination is defined by the formula E is equal to what? Flux by the area. So flux which is received on that particular area. So if I consider A1, so E1 for that area is 5 by A1. Now intensity, the another definitions for intensity. So illumination is flux by area. Intensity is flux upon solid angle. So we consider that I omega is equal to 5. So this is my equation. So I omega to is equal to 5. Now this law is applicable, as I stated earlier also, applicable only for the point source only. In the direction is normal, means perpendicular, then and then we can apply inverse square law. So again, S is the point source. A1, A2, A3 are three parallel surfaces. D1, D2, D3, yeah, I have stated D, 2D, 3D is the distance from A1, A2, A3 from the point source. Assume that I is the illumination intensity, omega is a solid angle made by the surfaces. So the total flux of the light on areas A1, A2 and A3 is equal to is, now we prove that. So the total illuminate flux radiated is I into omega. As we say, I is equal to, intensity is equal to flux by area. Flux by area. Flux by solid angle. Flux by solid angle. So I into omega is equal to flux. So the total illuminated flux radiate is I into omega lumens. Now we consider for area 1. So particular E1 is equal to again phi by A1. As we stated earlier also, illumination E, we just repeat the formula here also. E is the illumination. So E is equal to flux by area. Now for the area 1, we take E1 equal to flux upon A1. Okay. So the second equations, I, intensity of the light, is equal to phi by that solid angle omega. Okay. So we put the value of flux is what? So now what is flux? So flux equal to I into solid angle omega. Solid angle omega. So I put the value of this flux into this equation. So I get this. I get this. Okay, now we know that solid angle is, equal to area upon r square. Yeah, you can say d square. Our formula is area upon r square. Yeah, okay. So for this, we put omega is equal to A1 by d square, because here we consider a d, distance from point source to that particular area. Okay, now the illumination on the surface A1 is equal to E1. So E1 is equal to I into omega upon omega d square. Why it is? Because we put the value of omega over here. So I get A1 is equal to I by d square. Similarly, for surface A2, I get I omega by A2 So area of surface A2 is omega into 2d square. So I am getting 4 omega d square. So illuminations on the surface A2 is now I omega 4 omega d square, means I by 4d square. Now I can say I upon 2d square. Again I repeat the things. How I find out the illumination on the surface A1? Okay, so A1 is equal to the surface area omega into d square. Okay, omega into d square from this equations. So A1 is equal to omega d square. Okay, so A1 omega d square. Now I put all the values together. So E1 is equal to what? Phi by A1. Yeah, you can say I omega A1. Now I put, so A1 equal to omega d square. Omega d square. Here I put the value of what I, how I get this? I omega d square. Where I get this? Omega d square. Now I put the value of E1. So E1 equal to I omega upon A1. Now what is A1? A1 is this. So I put the value of omega d square over here. Omega d square over here. So omega is cancel each other. So finally I get I upon d square in this equation. Now for illumination on the surface A2, same way I omega by A2. Here what is A2? A2 is equal to omega into 2d square. Why? Because the distance from point source to that particular area A2 is 2d. So instead of d I am putting 2d. So 2d square. So it will get 4d square. So I put the value of 4d square. Similarly, I get I upon 2d square. Now go further. If A3, for A3, I will get 1 upon 3d square. So finally, from above equations 1, 2 and 3, we conclude that E1, E2, E3 means the illuminations for the area 1, area 2 and area 3 is 1 upon d square, 1 upon 2d square, 1 upon 3d whole raised to square. Hence the illuminations of a surface is inversely proportional. So we can say it is inversely proportional. So if I consider E illumination for that particular area is inversely proportional to the square of the distance of the source of light. So there is some limitations for this. This is true only if the source is a point source only. So this is the limitations of inverse square law. So this law is applicable for only the light point source only and perpendicular rays. So we overcome this. The second laws, Lambert's cosine law, we introduce. So illuminations of surface at any point is dependent upon the cube of cosine of the angle between the line of flux and the normal at that point. Second, while surface was normal to the light flux, but in practice this is not always possible. Now illumination for such cases is given by Lambert's cosine law. Now we consider these two figures, figure A and B. Now you see this in figure A, the angle between normal and the line of flux is 0. So this is line of flux, and this is the normal plane. So the angle between the both are in phase. So the angle between these two is 0. Now so inverse square law is applied. So for figure A we can apply inverse square law. Now consider figure 2, means figure B, second figure. So the angle between the normal and the line of flux is theta. So here we cannot apply inverse square law, but the cosine law will be useful. So the applications means you can find out the illuminations for that particular area. We have considered cosine law. So this is the statement of cosine law. According to the cosine law, illumination at any point on the surface means this is the point. This is surface. Okay, this is surface, this is point. So I consider this point O. So according to the cosine law, illumination at point on a surface is proportional to the cosine of the angle between, so cosine of the angle between the normal, so this is normal lines at any point and the direction of luminous flux, So we state that illumination is proportional to the cos theta. First inverse square law stated is proportional, E is proportional to the I by D square. Now finally we conclude that for this figure 2 means figure B, that E is proportional to cos theta into I by D square. Now we prove that. So here I take a source, point source over here. Okay, so point source, this is called light source also. Now we find a illumination at point Q, and R. Okay, so this is point 1, this is point 2. Again we consider that the distance between light source to that particular point Q is D. So D is the distance between P and Q, and R is the distance between P and R. So R is the distance between P and R. Now we find the illumination at point Q and R. So it is called EQ and ER and ER. Okay, fine. Now stated that PQ is D, the distance between PR is R. Now illumination E, as we state earlier also, E is proportional to cos theta, and E also proportional to I by D square. So we said that illumination at particular point is proportional to cos theta into I by D square. Now we take this equation. Okay. For first illumination at point Q. Now we consider this point Q and find out the illumination at particular point Q. So that is denoted by EQ. So EQ is equal to cos theta into I by D square, because the distance between P and Q is D. So we consider as cos theta into I by D square. So this angle, so the distance between this PQ is D, and the angle between this is 0. So theta is 0. So cos theta is unity. So EQ is equal to, I get it, cos theta is unity. So I get EQ is equal to I by D square. Okay, inverse square law. Okay, now at point R. So point R, ER equal to cos theta into I by R square. Why R square? Because the distance between P and R is P and this capital R is a small r. So I consider as I by R square. So here cos theta is equal to what? Cos theta is equal to d by r. Cos theta is equal to d by r. Now I take a cube. So cos cube theta is equal to d cube by r cube. Now ER is equal to, now I replace this value over here. So ER is equal to d by r into I by r square. So finally I get ER is equal to I d by r cube. Okay, r cube. So what I'm going to do now? I'm just multiplying d square upper side and the lower side by d square. So I get this. So I d cube divided by r cube into d square Okay. Now cos cube theta is equal to d cube by r cube. So here d cube by r cube is replaced by cos cube theta. So I put the value of d cube by r cube as a cos cube theta. Finally I get ER is equal to cos cube theta into I by d square. Okay, what is I by d square? This is I by d square is a EQ. So finally I get ER, means the illumination at this particular point R is equal to cos cube theta into E cube. So this equation number 4 state laws of cos cube. Yeah, you can say cosine law of Lambert's. Yeah, you can say Lambert's cosine law. So we prove that ER is equal to cos cube theta into EQ. Yeah, you can say I by d square. Okay. Thank you very much.